Hi, and welcome to this ZP Developer Zone webinar. So we like to do this every Thursday at 8 a.m. London time, but unfortunately I'm in a hotel at the moment and terrible internet. It's like 5 megabytes per second, so it's just not going to cut it. So I've actually pre-recorded this, and I apologize for that because I quite like to do them live. That said, don't forget there's the ZP Academy. I think a few of the questions this week, please log in, create an account in the ZP Academy. There's a couple of free courses on there that would be really useful. Also, of course, we do this webinar every Thursday at 8 a.m. London time, except today when, in fact, I'm doing it early because I have to get it uploaded because the internet's so bad. We do have collaborations. These collaborations are mainly happen at the moment in the UK and Norway because the funding situations are really helpful when working with academia. We did have 2 new signups last week, and we do have the ZP Developer Zone, and we do have workshops. The workshops are important because some of the questions that are coming in this week, they're really nuanced, and actually you can't answer these things in emails and a couple of chats. It's people need the formal training. That said, if a link appears, then I'll put it underneath the video so that you can find the link. But this is just to say that we did have a workshop, in fact, just yesterday in Coventry, and so I gave that workshop. And we do have a big workshop in September, and I'm really going to recommend that some of the questioners come to that workshop. We do have a big conference also running in Norway in September as well. So anyway, this link will be underneath the video. The workshops are one of the best places to get the training. As I say, we are having a large conference on all things sensing and digitization of essentially digitization of the planet, but starting with sensors. And for us, this is a way of making a sustainable, let's say, world. As I say, the link is there, so have a look at that. Now, question number 1 is really about conductivity. Person wants to understand about conductivity. They want to understand interpreting signals for a calcium sensor. They want to understand, do I or do I not need a chloride resilient electrode? And I will answer that. Somebody else wants to know if I recommend the SeedStat open source potentiostat. I mean, I don't recommend any of them, but the SeedStat's not a bad one. It's quite modern as well. When I say I don't recommend any of them, it's just because obviously, at ZP, we are a commercial organization. In the end, we do a lot of videos and a lot of free material, but of course, something pays for this, and it is it is things like the potentiostats. Somebody did ask about the cortisol sensor. I'm always very disappointed on the cortisol sensor because actually it's something that we reserve for really large clients and really large projects. So unless you've got a really large project with us, the cortisol sensor is something that we do kind of reserve it for really large projects. My apologies on that. Repeatability, I should have expanded this a bit, but we're really talking about repeatability of screen printed electrodes. In this workshop today, I'm actually going to recommend people our gold electrodes, our platinum electrodes, and our carbon electrodes. I recommend them because actually I think they're really, how can I put this, really repeatable. And I will then also talk about detecting heavy metals in, essentially in well water. So this is a really serious problem in the world, and I do appreciate the question because electrochemistry is actually a really good science for detecting heavy metals in things like well water, things like arsenic. And I understand why the questioner is asking us to kind of get involved here. Gold electrodes with a true reference. This is a question. The first question that came in is, can I have a gold electrode with a true reference? And I'll explain what I mean by that. Basically making it impervious to chloride, and the answer was yes. And then there was a real doozy, which is, and I want to roll it up in a very tight cylinder. That's a really tough, but it's doable, but just not with the standard materials. You'd have to go for something a lot thinner. Somebody else wanted platinum electrodes, and I will comment upon the platinum electrodes as well. So I'll speak fast because there's quite a lot of slides. First one is conductivity, interpreting signals, and chloride resilient electrodes. So first thing to say that at ZP we do have these courses. So with this particular questioner, I think some of your questions are making me think, please come to the workshops, because we have techniques that you will be needing to use in your program. Will probably be at least, I imagine, potentiometry, and I think impedance spectroscopy. I mentioned potentiometry because you're interested in ion selective electrodes, in particular calcium, and impedance spectroscopy because you're interested in conductivity. And just to say, obviously, you know, we do have this single purpose chip or single purpose circuit which can perform any of these measurements. In terms of conductivity, they're a little confused because I do have a page on conductivity sensors, and then I've sort of started highlighting to them, no, actually, I want you to use one of these other electrodes, and they were a little bit confused, but I'm highlighting at the moment. There was actually a link on that page, and I'll take you to where that link is taking you to. It's taking you to this page, which has also got a link on it, which actually says, look, you can use the ZP screen printed electrodes as conductivity sensors. We did a whole bit of work where we used many of our just standard screen printed electrodes and found out that they were perfectly good conductivity sensors, and I've got the data on this page here. The take-home message from this is these screen printed electrodes all worked pretty much the same. So when I recommend it, when I was recommending that electrode to you, it's because it was based on this particular piece of work. And the reason I'm recommending this electrode is it's so low cost. You have to do a bit of work, and I think you actually you have to play with frequency and amplitude to really get it to work. That's something that we would do, and I hope that it's something that you can do. So I've put a link here. I think the way forward in terms of conductivity is, when I say go on your own with ZP products, I'll detail that. Come on a training course at ZP, I super highly recommend that. Come onto a paid project consultancy with ZP, basically have us consult in and give you some advice. We do have out-of-the-box solutions, but I know you're an engineering firm, so you're not going to want to go that way, and I respect that. When I say go on your own, we do have FRA, a frequency response analyzer, or EIS, electrochemical impedance spectrometer. This is really that electrochemical impedance spectrometer. You will need connectors. If every time you see something with a link, I will put the link. You do need these electrodes. We also have some conductivity solutions, so you can sort of, I want to say, practice basically. So if you get those 4 items, then you're kind of you're in good shape, and you can get on with say developing the assay. I would recommend that you come to one of our training courses even before you get hardware. I would, apart from the screen printed electrodes, and the connectors, which are really kind of low risk because they're quite low cost, I would recommend you come on a training course, or at a minimum, you may need some paid consultancy to give you some advice, which is a bit more than just these webinars. We cover, obviously, at ZP, you know, we've been building a technology stack for a good 8 years around biosensing. So the idea that you could do a conductivity measurement on an electrode, put it on our Sense-It-All platform, make a connection with that app, send it to our Julie database, and get the results, you know, essentially on the phone. That's something that we do have. So we can give you an out-of-the-box solution, but I think because you're an engineering firm, you're not going to want that so much. But I link to it just for your interest, really. Now, you're interested in interpreting your calcium sensor. And I can see from the question you're asking, well, what kind of current should I be using? Absolutely no current. These are potentiometric measurements. Really, you have to make this kind of measurement with a high impedance circuit. If you have such a thing, great. In order to kind of interpret the signal and calibrate, you know, this is some data that I'm using the potassium sensor here. I know you were interested in calcium. It's just they all work the same way. So here we're testing at a concentration. We note the concentration and we note the signal. We change the concentration, we note the signal. We change the concentration, we note the signal. And we change the concentration, we note the signal. Now I've shown this in a kind of, it's kind of curving off because actually it's really following a logarithmic relationship. When you've got quite narrow concentrations, it can appear logarithmic, but once you start changing like 1 millimolar, 10 millimolar, 100 millimolar, you're going to notice that it's actually logarithmic. So then you do signal versus the log of concentration, but it doesn't matter. In the first instance, you have to kind of essentially calibrate, and then you can use the calibration curve to reinterpret what the signal actually means in terms of concentration. We do this kind of work in our courses as well. Starting materials for that is you need connectors and you need the calibration solutions. But I definitely think some advice could help as well, and so maybe some consulting could help as well. Do I need a chloride resilient electrode? Short answer is yes, I do believe you do need it. Why do I think that? Because you're not in blood where it's constant chloride. You're in a sort of, probably a much more of a pure water or variable chloride situation. So you will need a chloride resilient electrode. And we do have a solution for that, which I'm hopefully linking. No, not linking, but if you Google chloride resilient formulation, ZP10000988, hopefully that'll pop up and you'll be able to find it. So quick answer is I think you actually do need a chloride resilient electrode. We do have a formulation in order to do that. You're right, we do have some mutual friends, and so with our mutual friends we have been testing their new electronics on our glucose sensors, and they work really well. Question number 2 is really about open source potentiostats. So somebody wants to go to a 3 electrode system from a 2 electrode system. They're wondering if the seed stat is good for them. I was jokingly saying I didn't sort of give advice on potentiostats because obviously we're a commercial organization, but we are mindful to support the community. We do have a whole page around this about open source potentiostats. I've reviewed them all over the years: the CheapStat, the Oliview, the Arduino, this one from Thomas Dovolere, the PSOC rather, the Simple Stat, the Seeds, and the Seed Stat. I've got a lot of slides here, but I suppose it comes down to this. The Seed Stat is one of the more recent ones. When you look at the older ones, you start finding that the chips are kind of gone obsolete, etc. So the Seed Stat probably is a good one to actually play with. When I was sort of preparing these slides, and looking at each one individually, they're pretty similar actually. I mean, all of them, in terms of their performance. The PSOC's had a lot of work over the years, but I think it's got a Cypress chipset on it, and it's the only one that has that. And I've had some correspondence with the guy who made the C-Stat, and he's clearly really good. And it's it is quite elegant, and the voltammetry that comes off it looks pretty legit. So I don't have any problems with the C-Stat. So the quick answer is yes, I think it's fine. And it's in part because it's probably one of the more recent ones, and therefore the chips are still available. And this was, we are talking post-COVID now. Question number 3 is about Cortisol Center. I really always give a really bad response in this bin because we generally have a really good cortisol sensor, and we use it with clients, but it has to be with the large clients. People say, well, I would like to buy it, and we deliberately don't have it for sale on the web store. It's the same with the testosterone sensor as well, that we only use it with on large projects with well-funded clients, if I can put it that way. So I do apologize every time, but that is the situation that we're in. Somebody was also very interested in a gold electrode. I do get, when it's great to get inquiries about gold electrodes, I always make a recommendation on. And again, if you see a link, just know that I will definitely have. I will put it underneath the video so you can get hold of it. So I recommend the gold electrode. I do recommend it because it's particularly high quality, if I can say that way, and I've got some data that represents this. I do say, look, you have to clean gold electrodes before you use them, so we've got some cleaning solution for that, and you do have to have a decent connector, and I've got a decent connector for that. And I did also link to some potentiostats and some of the advantages of this rectangular design that we have. Something that makes our electrodes really good is actually the repeatability of them. So we're the only people who do this, that when we make screen printed electrodes, or at least do it in a very industrialized way, we actually get a number of sheets from the run. We check them by cycling voltammetry. We check their coefficient of variation, which is really the standard deviation divided by the mean, make sure that everything is fairly tight, and then we check all the sheets against one another. So I get I absolutely do not get complaints about irreproducibility of our screen printed electrodes. And I know that everyone is complaining about these R&D screen printed electrodes that you can buy from various vendors. And the reason I don't get the complaints is because we do a lot of checking before we ship them. And the reason we check them is because we use these screen printed electrodes all the time. And we also have quite a nice strategy for letting other people use these screen printed electrodes actually in their products as well. So I've got a couple of links there, and I hope that really helps people as well. This is a good one. When I say good one, I mean this is an important one. That I do understand that well water, when you have deep wells, you can end up having things like arsenic and heavy metals in the water. And I've put a few notes in here because this is something that we actually have worked upon. And I have recommended this carbon electrode. It will allow you to do a technique called anodic stripping voltammetry, and a connector as well, so you can make a decent connection with it. Question number 7, somebody was interested in a gold electrode, and they were particularly interested in a gold electrode with a sort of chloride resilient electrode, and I've sort of made that available, and I put some links here. And they wanted then to make it very flexible so that it could be put inside a catheter. These ones are too stiff. They are on a polymer. You can flex the sheet, but they're too stiff to roll up really tight. You can do it. I mean, I've got a bit of I was about to say, I was about to grab a bit of paper, but this piece of card that I just happened to find here, oops, a daisy. This piece of card that I just happened to find here is probably illustrative enough. Now, once you get very thin, you can definitely roll this kind of stuff out. I understand a catheter is particularly small, so it has to be particularly thin. So what you want to do is achievable. It's just not achievable on the standard materials that we put these gold electrodes on. It's, what would I say? Get your assay working on something that's quite standard, because if you go down the route of specialist materials, it's fine. I know you're in academia and you may have the time, but it's a long road. But the quick answer is you could make it on a very thin material, and they are available, and then you could, yes, roll it up and put it inside a catheter. You just can't do it on these particular materials. It's too thick, too stiff. It'll roll up to a cylinder about that size. So not is the answer. Somebody wanted some platinum electrodes, so I've made some recommendations on platinum electrodes. I'm a repetition of myself here that actually you will need a decent connector, so I've also linked to the connector as well. I've also given them where the data sheet is so they can look at the scale, and they were also kind enough to actually tell me what they were going to do, which is eventually put some polymers and catalytic material on the working electrode. We do this all the time. I mean, in fact, we were doing a workshop just this week where we were putting polymer and a catalytic material down, and we just essentially sort of pipetted it along. So I think the platinum electrodes that I've recommended to you will be pretty good for that. So question number 1, conductivity. You've got sort of, I've illustrated, let's say, 4 ways forward on that. Interpreting that signal, you can see that you have to kind of do a calibration curve. Chloride resilient, I think you will need it. Question number 2, open source to see that's pretty good. Cortisol Center is only available to large clients. My apologies on that. The gold electrode, we've got the hyper value gold electrode, it's pretty good. We make a really good electrode because we actually check them all before the batches before we actually ship them. Detecting heavy metals, I've linked to a carbon electrode and a connector I think that you'll need, and you'll need to learn and study a technique called anodic stripping voltammetry. Gold electrodes with true reference, I have made it available to you. What you want to do is achievable. It's just not achievable on the products that I've linked to, and I'd say practice your assay on something that's standard before you start trying to make a bespoke electrode. And those platinum electrodes, I have made those available as well on the website, and I've recommended them. And what you're trying to do is what we do all the time with those electrodes. So I'm sorry to have spoken fast. I'm sorry that this wasn't live, but thank you. And we will do the same next week with the questions that came in next week. Okay, thanks very much.